Hello and welcome back to another FSMQ series video. In today's video we're covering an entire topic in one episode, objective functions and linear programming. It's a very small topic, that's why we're doing it in one video, and also it's worth like a whole 5 marks in the exam just for free basically, once you know what you're doing. So let's get on with it. Lesson 5, let's go. So what do we actually mean by the term linear programming? Well, linear programming is comprised of two things: objective functions and constraints. Objective functions are basically equations/functions where you have two inputs or two variables that produce some other term, and you just derive that from information given. Same with constraints, you determine it from what you're given in the question, and they're just written inequalities that state where you can go, what bounds you, what's the feasible region of this objective function. And you can use both of those to work out the maximum or minimum value. You also use straight line graphs to plot the inequalities to work out that feasible region. Now a little bit more on objective functions just so you know what they look like. There's an example at the bottom there with the revenue being represented as R, cars and vans as C and V obviously, and then you multiply them by how much they cost. So that's basically what it looks like. So here's a bit of an example, just using the equation we had before. And I don't have a proper question here right now, but here's just some example restraints, like C is greater than 5 or some of the others. Then you plot them onto a graph, and the graph is usually given. It's usually like a 2-page question, so the graph is usually on the second page, and it will tell you to refer to the graph on the other page and plot all of the inequalities. So C is greater than 5, V is less than 13, and then C plus V is less than or equal to 17. So that feasible region we were talking about, where it's possible to exist, is basically that triangle you see there. And then you plot all the corners, but remember you can't plot it if it's not equal to as well. So choose the closest to the corner you can find. You see it's raised up by 1 for 1 and 3. Then work out the revenue at each of those points and then find the maximum or the minimum. And that's all you have to do. So let's get on with some practice questions. So here's today's practice question. A farmer intends to buy some hens of 2 breeds. Breed A costs £1.20 and needs 0.4 meters square of floor space, whereas breed B costs £1.60 but only needs 0.3 meters squared of floor space. The farmer cannot spend more than £1,000 and his hen house is 240 meters squared. Find the max number of both breeds that can be bought at once. And this is a question you could get in the exam. So first we need to make a objective function for this statement, both breeds that can be bought at once. That's pretty simple. We can say T for total is equal to A plus B. Then we need 2 separate restraints, one for cost and one for floor space. So let's make them now. We have 1.2a plus 1.6b is less than or equal to 1000, and 0.4a plus 0.3b is less than or equal to 240. Now we can put these in a way that can be plotted on a graph. So to do this we can multiply by 10 on this one, and then divide it all by 12. I forgot to do this here. And then A is less than or equal to minus 4 over 3. B plus 2,500 over 3. And for this one, it's more simple, multiplied by 10, divided by 4. There we go. So there's our two different lines that we're going to plot on this conveniently already made graph. So these are our two equations, but they're very complex, so I suggest use a calculator. I suggest using the table function on your calculator, and all you're going to type in, f of x is basically the same as a, so we're just going to type in minus 4 over 3 x plus 2,500 over 3, and then the second is minus 3 over 4 x plus 600. Right, we want a total range, but the calculator gets a bit fussed on doing large amounts of ranges, such as 0 to 630. So, as such, we are only going to do up to 280 first, so 0 to 280, and then do it in steps of 10. So then we try to find the nearest whole number ones that we can plot easily. We only need 2 points. So our first equation, we can use our first one is, check 740. Here we go. But that's not on our graph because it only goes up to 700. So we keep looking. 140, not a whole number. 210, not a whole number. 280 is 460. So 280, we go up here. 450, 460. Then we're going to need to hit back, go through, and then we're going to replace this with 290 all the way up to 560, which is the second to last one here. Again, up in tens. It takes a moment. And then we keep looking through, so we want to go to 350 next. Not a whole number. 420, not a whole number. 490 is a whole number. It's 180. So we go up to 180, and then we mark it, and then we're going to use our ruler and draw a line between them, like this. You would continue it up in an exam. I'm not going to bother because, you know. And then our second lot, go back to our other list of values, 0 to 280. Obviously we can work out from this, if b is 0, it's going to be 600, so we can plot 600 straight away. The next value we look along, 70, no. 140, yes. But that's a hard one to plot on our graph, so we're going to keep moving. 10, no. 280 is 390. That's one we can plot. So 280, we go up to 390 here. And then again, ruler, connect. And now we can see that they overlap. So there's going to be 3 spots we're going to test. We have the one down here, which we're going to call number 1. We have here, which we're going to call number 2. And we have up here, which we're going to call number 3. Now, I think we can automatically discredit this one, because this one down here, sorry. Because this is very clearly less than the 600 up here. And remember, we're just finding the total for this one, so it's pretty easy. So we can discredit number 1. I'm going to cross this out. And now it's just between 3 and 2. So I think for this, we're going to need to work out what 2 is. So we're going to draw a line down. And that hits about there. That's 3 from 350, and it goes up in 7s. So we're going to take our calculator, we're going to switch it back to the normal mode, and then we're going to go 350 plus 3 times 7. And this is 371. Then we need to go along. So we take our ruler, draw along, and it's 4 above, and this goes up in 5s, so it's not that bad. So that's 340. So now we can work that out back on our normal piece of paper. We have 340 plus, also wait, it goes up in 10, so what am I talking about? This is not 340, this is 320. 320 plus 371, which in total adds up to 691, which is greater than 600. So we know that our answer is going to be this point number 2. So the maximum is 691, and that's your answer. Welcome to the 4 marks section of today's video. In this section, I give you the 4 different questions on 4 different aspects of this one topic. Obviously, today's topic is going to be objective functions and also linear programming. So we have the pure, applied, proof, and riddle questions here for us today. Go ahead and choose one of them or all 4 of them if you really want to, and come visit me in a second to see the answers. Okay, so let's get on with it. For our pure mask today, you actually get given all the stuff you need to begin with. There's no deciphering like the practice question we did. So I think this is just the simplest. Maximizing P, you just got to plot it onto a graph and look, it's 0.1 or 2, you know, the biggest. And then make sure you write out the full thing, including X and Y. For our applied mask, this is a bit more like what you're actually going to get in an exam, I think. So obviously this is all one question, but usually they break it down into smaller parts in an exam. All you really have to do is write down the objective function and all the different inequalities you're going to need. Obviously you can't have less than 0 of either product because you can't have negative products. And then once you've done this, you're going to want to plot them into a graph and then go from there. And the answer is 0 sandwiches and 20 drinks. Then for our proof question, I would say it's a pretty easy proof question today. All you have to really say is that if A is greater than B, already stated, then X is greater than A is already going to mean that X is greater than or equal to B. So you can just get rid of X is greater than or equal to B. Then for our riddle mask, we've got a bit of like a substitution kind of question as the main part of it. This is actually pretty simple. It's not something, I don't think you're going to get something too much like this. It's a bit too easy. But you know, maybe. And then as the bonus, here's all the different lines that connect them. Thank you for making it to the end of the video. In the next one, we'll be going through algebraic fractions, so more crossover content. I have a worksheet for this lesson in the description. Just copy and paste it into your browser. Feel free to comment any questions you have. I respond for a week after posting. I have a half-termly article also that I release. This half-terms was on what's the best way to teach maths and how do students respond. Thank you again and goodbye. I'll see you in the next one.